Hey there, and welcome to this explainer brought to you by QandAHelp.com. We are going to take the stress right out of your exam prep today. Let's gently walk through a very specific, real-world WASSCE Mathematics past question to help you gear up for your upcoming exams with total confidence. You know, math isn't just about memorizing random abstract rules. It's about seeing how the numbers actually work together in front of you. So we're going to work through the exact numbers, the formulas, and the steps completely together.
All right, let's jump straight into the deep end with this WAEC question. We need to find our target variable z using the clues they've given us. The problem states, a variable z varies directly as x and inversely as y. If z equals 12 when x equals 4 and y equals 5, find z when x equals 6 and y equals 45. And we've got four possible options here. A is 2, B is 1 over 9, C is 112.5, and D is 15. Now, don't let all these numbers hitting you at once overwhelm you. The trick is to just build the correct variation formula first, piece by piece.
First things first, let's break down that opening sentence and translate the math into plain, everyday English. It says z varies directly as x. Mathematically, we write this with that little proportionality symbol. Z is proportional to x. But what does that actually mean for us? It simply means that if x goes up, z is going to go up too. They're on the exact same path. It's kind of like buying apples, right? The more apples you buy, let's call that x increasing, the more money you have to pay. That's z increasing.
Next up, the question throws in that z varies inversely as y. Now, mathematically, this looks like z is proportional to 1 over y. Inversely just means the relationship is totally reversed. If y gets bigger, z actually gets smaller. A really good way to think about this is sharing a pizza. If the number of people sharing that pizza, our y variable, increases, well, the size of the slice you get, which is z, is definitely going to decrease.
Okay, so the absolute crucial point here is that by smashing these two ideas together, we get our master relationship. Since z is direct with x and inverse with y, we can say z is proportional to x over y. But we obviously can't solve an equation that just has a proportionality sign in it. To turn it into a real, workable equal sign, we have to introduce a constant. We usually just call it k. So our core foundational formula becomes z equals k times x, all divided by y. From here on out, every single number we plug in will go right into this specific formula.
Now, it's super helpful to organize our clues, clearly separating the initial values we already know from the new target values we are trying to figure out. Think of it as two sets of data. Our first set of given values is z equals 12, x equals 4, and y equals 5. Our second set, the targets, are x equals 6 and y equals 45, and we need to find that missing z. Our game plan is simple. Use those first known values to find our constant, k. Once we've got k, finding the missing z is going to be a total breeze.
Let's actually build this out mathematically, step by step. Step 1, we just plug our knowns into z equals kx over y. That gives us 12 equals k times 4, all divided by 5. Now we just need to do some algebra to get k totally by itself. Step 2, let's multiply both sides by 5 to knock out that denominator. 12 times 5 gives us 60, so now 60 equals 4k. And finally, step 3, we just divide both sides by 4 to isolate k. 60 divided by 4 leaves us with our constant. Boom! There it is. 15. This number is literally the secret key to unlocking this entire puzzle. This constant, k, does not change absolutely no matter what wild new x and y values the examiner decides to throw at you. Because we have that constant, we can lock it in for good. Our official, upgraded working formula for the rest of this problem is now z equals 15x divided by y. Notice how much more powerful this equation is now? We've swapped out that annoying, unknown k with the actual number 15. We are now in the perfect position to find our target z.
Let's grab those target values we saved for later. X equals 6 and y equals 45. Step 1, we just drop them straight into our shiny new working formula. So z equals 15 times 6, all divided by 45. Step 2, simplify that numerator. 15 times 6 gives us exactly 90. So we're looking at 90 over 45. Step 3, do the final division. 90 divided by 45 gives us a clean, super satisfying 2. We actually found our z.
But hold on a second. Before we wrap this up, let me show you a real pro shortcut. If you're sitting in an exam room for WAEC or JAM, you know time is everything. Instead of doing the traditional method where we have to stop, find k, rewrite the formula, and substitute again, you can actually set up a direct ratio between the new and old variables and skip finding the constant k entirely. It looks like this. The new z over the old z equals the new x over the old x multiplied by the old y over the new y.
Let's actually see this shortcut in action with our numbers so you can see how cool it is. We want our new z, right? Let's just call it z2. So we write z2 over our old z, which was 12. Now for the x part, because it's a direct variation, we keep the order exactly the same. New x over old x. That's 6 over 4. But watch this y part closely. Because it's an inverse variation, we completely flip the y fraction upside down. We put the old y on top and the new y on the bottom. So that's 5 over 45.
Now, we just multiply those fractions straight across. 6 times 5 gives us 30 for the numerator. 4 times 45 gives us 180 for the denominator. So, z squared over 12 equals 30 over 180. And wouldn't you know it, 30 over 180 reduces beautifully down to 1 over 6. See how nicely these numbers play together when you lay them out the smart way? Finally, to get z2 completely by itself, we just multiply both sides of our equation by 12. That gives us z2 equals 12 times 1/6. And 12 divided by 6 equals exactly 2. We arrive at the exact same answer, proving this shortcut is a fantastic time saver. Whether you use the constant method or the shortcut method, the math definitely doesn't lie.
All right, let's lock in this knowledge with a super quick quiz just to make sure these concepts are totally rock solid before test day. If variable a varies directly as b, what does that formula look like? Is it A equals k over b, B, a equals kb, C, a equals b over k, or D, a equals k plus b? Think back to our apples analogy for a second.
If you guessed B, you hit the nail right on the head. Direct variation means multiplying by a constant alongside your variable. As b goes up, you multiply it by k, and a goes up right along with it. So a equals k times b is the perfect translation of that relationship.
Let's try another one. Quick quiz 2. What if p varies inversely as q? How do we write that out mathematically? Look at your options. A, p equals kq. B, p equals k over q. C, p equals q over k. Or D, p equals k plus q. Remember the pizza analogy here. More people sharing means a way smaller slice for you.
Yep, you got it. It's b again. Inverse variation requires dividing that constant by your variable. As q and the denominator gets larger and larger, the overall value of p shrinks down. It's a fundamental rule of fractions that you are literally going to use all the time in math and physics.
Let's do one final rapid-fire logic check. Looking back at our main formula from today's problem, z equals kx over y. Without doing any actual math, just thinking logically about the basic structure of the equation, what happens to the overall value of z if that y on the bottom gets larger and larger? Exactly, z decreases. Because y is trapped right there in the denominator, any increase in its size is going to cause the total value of the fraction, and therefore z itself, to drop. Understanding this underlying structural logic is honestly just as important as knowing how to crunch the actual numbers.
And that brings us full circle right back to our original problem. This completely confirms our final result for question 36 is indeed option A, which is 2. So be sure to head on over to QandAHelp.com for even more WAEC, JAMB, and GCE exam mastery. But before you go, I want to leave you with something to chew on. What other relationships in your daily life actually operate on direct and inverse variation without you even realizing it? What hidden equations are you unknowingly living out every single day? Keep looking for the math around you, and I'll see you in the next explainer.